the audio source in. Let's see, let's switch over to, please wait, and make sure that the audio is good. Looks good. Okay. So, and I need to change the channel defaults because we're not actually playing Kerbal Space Program, which is what the last setting was. So anyway, all right. So hopefully, Mr. Hidalgo, you're there on the Twitch chat, and so just sound off so I know you're actually awake and alive and all that good stuff. There he is. Yep. Okay. Excellent. So, let's get to it then, shall we? You guys, here's the Canvas page. You guys had a chance to take a peek at it, sort of, yeah. All right, so we have to dispense with the boring stuff at the beginning, the stupid syllabus. And let's switch over to full screen so that Thomas can see it too. So we've got two sections of the course. Obviously, this is the 8 o'clock section. Then there's another batch of victims later this morning. And I know it seems kind of funny that the very first thing I'm going to talk about on the first day is the very last day of the course, but we kind of have to do that. So you guys, I mean, since you've all been here at least a semester, you know the deal with the final exam time slots, right? So you just go to the registrar's website and there's a big list. If your class meets at this time, then your final is at that time and so on, right? Well, what do you do though if you've got two sections of the class and you want them to do the same thing together? What's a man to do?
Don't listen to the registrar.
Well, okay, except the registrar has an out. There is the little known Saturday time slot, multi-section courses or things otherwise assigned by the registrar. I've only had to use it once in my career to do a Saturday morning final. Don't worry, I brought donuts. It was because otherwise I would have been going to The Hague to be tried for war crimes. But yeah, anyway, so because of that, and because I've got the two classes, your final, which will totally not be an exam, by the way, we're going to do on that Saturday. Now, the good news is that at least this time around, because we've got that weird, split over the weekend final thing, Saturday is sort of in the middle of finals, not at the very end. And so really it will be no disruption for you guys from usual life. And I'm going to have to TBD a lot of the details here, at least for a little bit because of COVID and whatnot. Basically, what I want to do is like a final exhibition of y'all's stuff, okay? Almost like an art show or something. And how exactly we'll do that? I mean, I would like to be able to just like have coffee and donuts and things in the library, and people come and sit down and play a game and look at your stuff and talk with you and then leave. Probably because I think it's a lot to ask for the country to have the vaccinations all magically rolled out by the beginning of May. We'll probably have to do it online on Twitch, which is what I did last semester with the CS101 class. And other than a few minor technical hiccups, it worked pretty well, I thought. Ethan, what'd you think? Yeah, okay. So yeah, we had some lag issues with the Discord stream and whatnot, but otherwise I think it worked pretty well. So yeah, so that's sort of the backup plan if we're sort of forced to do that. But I'd like to do it in person if we can, but since there's still so much uncertainty with where we'll be with all this nonsense by May, then we'll just have to TBA it. So we'll do it in the afternoon or maybe evening. And there's no reason to do this in the morning. I mean, who wants to wake up in the morning on a Saturday to go play video games? Like 8-year-olds. Yeah, or Mr. Rector. So, yeah. Like, I don't like to be out of bed before noon on Saturday if I can help it. What about you guys? Yeah. Okay. Mr. Rector, what are you getting up at 6:30 for a run and cakes and eggs? Okay. Okay. Fair enough. Now I get up like at 7, I feed the dog, and then we go back to bed. So, yeah, it's pretty nice. So, all right. So yeah, the real reason for this though is that it's going to be a lot more fun if we can just have both sections together doing the same stuff. Um, and so that's why we've just got to do it this way. Anyway, so what are we going to do? You guys all read the course description. So basically, we're going to start with a few weeks of Microsoft Make Code, which is very much designed for kids, but I think it's a good place for us to start to get some ideas in place. Um, and then we'll switch over to Unreal Engine after a few weeks, and that's where the rubber will meet the road. Because Unreal Engine, if you guys have all probably played games that used Unreal Engine, the least, probably the most popular, well, I don't know about popular right now, but are you guys still playing Fortnite, or is that a dead thing? Okay, good. Because if anybody still plays Fortnite, you can drop the clap now. Um, yeah. So anyway, so Fortnite, of course, is made by Epic Games, who made the Unreal Engine, um, and the Unreal Engine has been around for a long time. So it first came out in, oh goodness, it was I want to say like 1997 or so was when the first game that was powered by Unreal came out, and it was called Unreal. Um, and it was, believe me, for 1997, it was pretty unreal. It was really really amazing, um, and spent a lot of time with both playing it and then doing editing stuff for it. It's matured considerably since then, both in terms of its power, but also like in terms of like graphics capability, right? Of course, graphics in 1997 and graphics today are not the same thing. I mean, in 1997, a lot of people didn't even have 3D cards. So they were running games mostly in software rendering, which you can imagine how. Well, okay, let me give you an idea. What resolution do you play your games at on a computer or console if you're one of those dirty noobs? Like what, huh? Yeah, 1080p probably, maybe 1440p. If you were really like, if we got any Fijis, then 4K, right? Uh, Actually, many years ago in computer science 101, we did an activity where we disassembled a bunch of old computers and then put them back together, and it was a lot of fun. But then their homework assignment was to basically go to Newegg and pretend that they were building a full computer and pick out all the parts, set a budget and then build a machine to your budget and your needs. And one guy is like, "Well, my daddy's a Fiji, so money is no object," and then proceeded to build just like this outrageous gaming rig. Yeah, it was kind of funny. Um, anyway, so yeah, you play it, maybe 1080p probably at minimum nowadays. Back in the day, software renderers, we were playing at 320 by 240. Okay, so yeah, on CRT monitors, like old tube TVs, basically. Yeah, you kids these days have no idea. Okay, anyway, so the engine has become much more sophisticated to the point where, so the original Unreal game shipped with the level editor for it, so you could build your own like little worlds to run around in. And that's basically all you could do. You could do a little bit of programming, but mostly that's about all you could do, right? Was to build your own levels and design stuff. And if you wanted to do anything more complicated than that, You had to have a license for the engine from Epic, which was a lot of money, and basically only game studios could do that sort of thing. The gaming industry has shifted, or the game engine industry has shifted a lot since then. So in the 2000s and 2010s, you guys have probably heard of Unity, a game engine. It came out, okay? And the idea behind Unity was that it was free to download, and then all you did was, if you built a game with it and that game made money, then you paid royalties off the game to the people that made the engine. And that has been, some of the software industry has kind of moved in that direction. So now Unreal Engine, its complete source code, is basically free, right? You can go and download the whole thing today and see how it was built, right? And how they make their money, well, two ways, right? Is if you ship a title that's making more than some, like $1 million a year or something, then you owe them a cut of the money you take in. And then, of course, the other way that they make money is, well, how do you distribute your games nowadays? Yeah, in a game store, right? Nobody goes to GameStop anymore to buy a PC game, or hardly anybody. Um, you just download it from one of the too many game stores that are online. Um, and of course, Epic handily makes their own, or has their own game store from which they take their requisite cut. So that's how they make money. Of course, they also make money because people who play Fortnite pay real money for stupid cosmetics, and they have just made it's like owning a printing press for money, right? You just print your own money. There you go. So yeah, it's kind of ridiculous. So anyway, because of that, Epic has just a shit ton of cash laying around, and they've poured a lot of that money into the engine development, into the game store, into some of the stuff which we could argue about whether or not it's a good thing, but like the exclusives on the game stores, right? Where, like for example, Borderlands 3 was 6 months Epic exclusive, and then it rolled out to Steam and the other platforms. Epic basically paid uh, Gearbox, which is the developer of the Borderlands series, uh, paid them money to do that so that they would have the exclusivity. Anyway, uh, so yeah, so we're gonna do a lot of stuff. Um, we're gonna start with MakeCode. We'll move over to Unreal Engine. You guys are gonna be doing a bunch of blogging. We'll talk about that a little later. Eventually, uh, if you've got a big software project of really any sort, the problem is, well, imagine that you guys, like, let's say you had to do a group paper or a group presentation, right? Nowadays, how do you guys do that? Like, to work on it? Yeah, you use Google Docs. Okay, what it would Sheets, Docs, presentation mode, whatever, right? And the beauty of that, benefit of it, is it's live collaborative editing, right? So you can all be working on stuff at the same time, and nobody has to save a copy and send it to by email to somebody else, and then copies and paste, right? So it's Google Docs makes it real easy. There is only one version; it's whatever's on the cloud, and then everybody's editing it at the same time, right? Um, so with big software projects, though, there's not really an equivalent for big chunks of code. What you do instead is you use a version control system, such as Git. GitHub is sort of an instantiation of it. And what you do is it's sort of almost like a library. You check something out, you do something, and then you check your changes back in. And if somebody else has made other changes, then you have to worry about merging things or making sure that like if I'm making world one and you're making world two, it's okay for us to both check out and then check back in something because we're not editing the same stuff. Um, So we'll talk about that again later. That's obviously only relevant once we have sort of group collaborative work. Um, when you're doing stuff individually, it doesn't really matter, right? It's just you. Um, okay, so we'll do some online blogging. Basically, uh, the game design process, frankly, is almost identical to a good writing process. Okay, so where are my Div 2 majors in the room? Do I have any? Like rhetoric, history, yeah. Okay. How do you guys write papers? Mr. Pine, I'm going to pick on you. How do you write a paper? Yeah. Right. And then once you've got something written, then what? Exactly. Right. So there's a very iterative nature to it, right? If you're writing, okay, if it's a 2-page paper for EQ, you write it the night before. Okay. But if it's anything beyond that, if you're writing it the night before, you're doing it wrong. Okay. Yeah, you might get your C and move on, right? But um, good writing requires that you think about it in advance, you write stuff, you outline it, you go do research, you have annotatability, right? There's a lot of different steps. And most importantly, when you put something together, you go back and you edit it, right? And uh, good editing does not mean using spell check, right? Good editing is something completely different. So when is the stage when you do the spell check and make sure the commas are all in the right space and stuff? Like that is literally the very last step, an hour before you turn it in. Okay. And if you're worrying about commas and spelling and a bunch of that little nitpicky stuff on your first draft, you're doing it wrong. There's no point in being all worried about the commas when half those sentences are going to radically change anyway, right? So good game design mirrors this principle where you start with really rough looking stuff, okay, and then you progressively add detail to it because if you, for example, are building well, there's one thing that you guys will do, a detective's office. Like, so imagine sort of an old film noir, um, kind of like, desk with the cigarette, tray or whatever, uh, and it's raining outside, and there's sort of like dark jazz playing. Um, I would say actually Fallout, like Valentine, right? Imagine that kind of guy, right? So you want to build, say, his office, right? Well, you're not even going to put in the desk until like 3 or 4 layers into it. Now you might throw in like a block, like or like sort of a stick figure, sort of like this, which I guess everybody. What is this called again when you this pose? Yeah, T pose, right? Because that's right. Because it's big in cyberpunk right now. Because if you ride the bicycle, right, then the character T poses because it's a bug. Um, Okay, anyway, yeah, T-posing, thanks. So right, so you maybe throw in a character in a T-pose, just a quick rough asset, and you block off like a big cube, like, okay, here's roughly what the desk is going to be or what size it's going to be. And then on a later pass through is when you start putting in the actual assets that actually look like desks. And in a real, game development studio, right, then that part's going to get passed off to an artist who's actually going to make the desk and make it all ornate and stuff, separate from the designer who's actually sort of putting the things together in the world. And there's this complex, iterative, collaborative process to do all of that. So anyway, but it's just like good writing, right? That you're going back over it over and over again. Okay. Um, Unreal Engine has pretty steep system requirements. These are the bare minimum system requirements that this thing will run on. Okay. It will run on a dual core processor, but it's not going to run particularly well. Um, this is kind of funny. Is anybody still running a 400 series graphics card? Well, okay, first off, how many of you guys have desktop PCs? Okay, what about gaming class laptops? All right, what about the rest of you? Just a Mac. Okay, great. 13-inch, 15-inch? Okay. Yeah. So they have pretty steep system requirements, and it's not going to work particularly well on, it'll run on laptops, it'll run on your Mac, won't run particularly fantastically. And in particular, when you do run it, get ready for the jet engine. Right, the fans are going to spin up big time because it's going to be super using all the processing power. Now, fortunately, all the machines at the back of the library are pretty beefy desktops, right? So the PCs are all pretty decent PCs. They've got like 1060s or 1070s at minimum in them. Some of them have Radeons instead, but they're all pretty beefy machines, the iMacs included. They have discrete graphics cards, and we'll be able to run this pretty well. Okay, so you are certainly able to use those machines in the back of the library. And in fact, after a few weeks, once we get into Unreal Engine and start to get comfortable, we'll actually move over there and have class in the library rather than here. Okay, for the most part, so that we can do stuff during class on machines that are actually able to run this stuff. All right, so we'll have little assignments and big assignments. Big shock. Grades, blah. I don't want to have to do any of that. The other thing is, so I didn't have to do this today because you guys were good, but I had to kick out half my calculus class yesterday because they hadn't done their damn COVID app before they showed up. That made me a sad panda. Okay, so don't do that, right? Show up with your COVID. Now, if you have a stop or can't come to class for some other reason, right? Like if you're, I don't know, if Sparks did a number on your gastrointestinal system, don't come to class, right? That said, if you're able, please be on Twitch and Discord. And if unable, well, one of the benefits of me twitching all of this stuff is that then there's recordings, which I dump over to YouTube. Not every day we'll have a Twitch or YouTube stream, though, because there's some of the days where I want to do sort of like studio time where you guys are working during class rather than me streaming. Yeah. Now, this is particularly important when we get over to the library. You guys need to, but it's also true here, show up early so that you can clean the stuff before you use it. And we need to make sure we clean the stuff after we use it. And that's especially, I think, true over in the library where those machines get a lot of use. And I don't want you guys catching COVID because of touching a dirty keyboard. Okay. Yeah. And don't miss class. And I had a real fun writing this line, right? This is one of the beauties of teaching at a private all men's college, right? Is that you can put things like this in your syllabus. Yeah. So, yeah, don't do bullshit. All right, we talked about the final, sort of like an exhibition thing, and the other thing, like, look, it's 8 in the morning. I would much rather still be in bed, also, right? Twitch is not there because your pajamas are more comfortable than trudging through the icy sidewalks to get to class. Okay, so if you're on Twitch, it's because you can't be here in person. Yeah. All right, so any questions? Basically, just don't be a douchebag and we'll have a great semester. Okay? All right. All right, so let's sort of get started. So let's talk about MakeCode. If you go to makecode.com, there's a lot of different things you can do with it. but in particular, we're going to use Arcade. And Arcade is sort of, well, first off, it's visual coding. It's designed for novice programmers, which is to say, children, um, generally. Uh, and it's completely graphical, although you can program it in sort of Python-like stuff, which is nice if you know some of those things. And now, those of you who, because a few of you I know have taken 101 with me, we also did Scratch, okay? How many of you guys did Scratch or maybe even Make Code when you were in high school, middle school? Yeah, what, Scratch? Okay, anybody else? No? What did you do again? Okay, so yeah, Make Code's relatively newer compared to Scratch. Scratch has been around for a long time. And they're both sort of kid friendly. You can make simple video games, stories, animations, that sort of thing. But one of the things I like about Make Code, which I only just started using last semester, um, is how it handles object-oriented style programming. And we'll talk about what that means here in a minute. But the sort of the analogy I want to use for why we're going to start with this and then transition over to Unreal Engine and how we're going to do things, at least at the beginning, is as follows. And I have to admit that I'm completely ripping some of this off from a guy named Alex Cataldi, who is the senior education evangelist, right? That's a pretty cool title, at Epic Games. Okay, so he, or not Alex, it's Luis. What am I saying? So he's basically oversees a lot of the education market stuff for Unreal, for Epic, which includes Unreal Engine, a lot of the online learning. Uh, Unreal Engine is being used at there are art schools that are. I mean, you can like go to game design college if you wanted, right? Where you spend all 4 years um, learning the whole process, and then you end up with probably a bachelor's of fine arts of some sort. Um, so yeah, so the analogy he used would be if I fired up Unreal Engine and I told you, okay, this thing can make games. It can do a lot of stuff, right? You can make games, you can make architectural visualizations, you can use it to make a movie, right? Like there's all kinds of stuff you can do with it. Would be a bit like, let's imagine that we all drove to Home Depot and we all walked into Home Depot and I said, look, there's all this stuff here in Home Depot. Build a house. Right? You could, right? Pretty much everything you need to build a house and furnish it, or at least start to furnish it, you can get at Home Depot, right? I think the only thing you wouldn't be able to get is the actual HVAC system itself, but all the ductwork, you could totally get that. Hot water heater, yep, that's there. All the wood, masonry, all the plumbing, right? Okay, so I could just say, here you go, build a house. All right, now imagine if we did that, and let's say I gave you an unlimited budget too, right? That dispense with the pecuniary details. You've got a lot of grass and an unlimited budget, and everybody in the class, and maybe a few pickup trucks. Okay, what kind of house are we going to end up with?
Not a good house because no one knows how to build a house.
Right, it's going to be a disaster. Right, it might be kind of a funny disaster to see you guys do that. It'd be almost like when we say, "Okay, build a float." Uh, and then we end up with some real interesting assemblages, shall we say. Um, yeah, but that would be ridiculous, right? So what would be better would be to say, okay, there's a lot of things in Home Depot. Let me show you how, like, has anybody had that experience where like your toilet starts like every 30 minutes you hear the water run a little bit? Okay, what's the problem if that happens? Okay, either the chain's twisted or the flapper is leaking and needs to be the rubber seal and you need to replace it. Okay, so you go to the appropriate aisle, you get the appropriate thing, you open up the tank, you fix it, and you're done, right? Simple task. Okay. Um, what about if an electrical outlet in your house goes bad? Right? It's rare, but I've had it happen. Well, you go, you get the replacement outlet, you turn off the circuit breaker, you pull out the old one, you put in the new one, wire it up, and then you put the circuit, turn the circuit breaker back off, right? Pretty simple. Okay. So uh, it would be more reasonable to say, okay, let's talk about how to build a plumbing system. All right, well, to do that, let's talk about toilets, right? Or bathtubs, or how to put pipes together. Um, and then separately, we'll talk about electrical systems. And then separately, we'll talk about woodworking or whatever. And then you would be able to build a house. Okay, now it's still, like I said, a crude analogy, but forgive me. Okay, us starting with make code would be a little bit along the lines of, okay, before we start worrying about building actual house stuff to eventually build an actual house, let's build a Lego house. Okay, and let's also pretend that maybe you've never used Legos before, which, this being a men's college, if none of you played, everybody did have Legos when they were kids. Please tell me. Okay, just checking. Um, yeah, so that's sort of where we're going to start with it. But also, it means that the learning curve will not be, because if we jumped into Unreal Engine immediately, the learning curve would be like climbing a cliff. Okay. So I don't want to do that because it'll frustrate you guys and we'll just spin our wheels for weeks and it's not going to be productive time. So that's why we're going to start with make code. Okay. So let me just create a new project here. And um, the make code was sort of designed for making like old Game Boy Color style games. In fact, you can buy hardware that will run this stuff. So let me actually just show you guys because it's kind of cool. This little guy, right? So it comes with, here's maybe there we go. All right, so it's like a tiny little Game Boy style thing, right? You can, you basically program it online, download the code down to the machine, and then you can play it. It's got, a D-pad or, well, joystick, an A and a B button like a classic old Game Boy, and then the two white buttons down at the bottom are start and select or whatever. Um, and at this point, right, then we all have to say up, up, down, down, left. No, yeah, the Konami code. Okay, select, start. Yep. Okay. Anyway, so yeah, so that's what this thing's designed for, right? Is sort of Game Boy style things. Um, in particular, then, and this will be kind of an issue, not a problem, but an issue when we program stuff is that unlike Scratch, which has mouse support, this game engine is not designed for the mouse to be involved at all, right? It's designed where if you want to program a cursor, you have to have a cursor. But all of the controls in terms of the directions of stuff, everything is going to be purely in terms of the D-pad and A and B, okay? Um, and if you're playing on a computer, then of course you're going to map A and B to, like, say, the space bar or something, right? So it's not like it has to be the actual A and B key, because your D-pad on a computer, right, will be ASDF, your usual, or WASD, sorry, your usual, four keys for movement. Okay, so all of this stuff is organized into little tabs, and this would be kind of like, to beat our analogy to death, kind of like the different aisles at Home Depot, right? The plumbing stuff is on this aisle, the electrical stuff is on that aisle, the lumber's over there, masonry's over here, right? Like it's not all just jumbled up. Um, okay. Um, and the sprites, which are objects, okay? So let me just create one here. Okay, and you guys, there's a little sound effect that plays when you plop things in, which obviously you couldn't hear. But if I go to assets, okay, is where all of my art stuff is going to be. And now in this engine, obviously, your assets are basically all just 2D graphics or possibly sound effects. Okay, but basically it's just graphics. That's it. In Unreal Engine, your assets are going to be lots of different kinds of things. So you can have what are called static meshes. So that would be like the table. Okay. It's going to be something that's modeled in 3D software, not Unreal Engine. You use separate stuff for that. Um, and then you're going to apply to this static mesh different materials or textures. Okay. So that like the wood part looks like wood, the top surface sort of looks like that material. But you could take the same static mesh and you could apply like, well, I don't know, something ridiculous like gold to it. Okay, and have a giant gold desk. Same shape, same model, different materials been applied to it. Okay, so two different kinds of assets. You're also going to have, of course, 2D art for things like the user interface, um, title screens, things of that sort. Um, you're going to have tons of audio. Uh, well, what else would you have? Particle effects, make it, imagine you're programming like Fortnite, right? What all is there in Fortnite? And this is where you all say, well, we don't know, Dr. McKinney, because none of us have played Fortnite because we're not scrubs. No, I'm kidding, obviously, right? Right, but what all's in Fortnite? Okay, get your player. You got all the guns, okay, and in multiple forms too, right? Because there's the gun when it's sitting on the ground, having not yet been picked up, and then there's also the gun from your point of view or somebody else's point of view of your character holding the thing. Same thing with all the different items and power ups and stuff like that you get. You've got the circle thing, right? The storm or whatever that shrinks. You've got the actual world map, like terrain. There's foliage along that terrain, um, trees and plants and stuff. What else do you got? Yeah, so you got to have materials for all of those things. There's all the buildings, which, by the way, are of course fully destructible, right? And so really they're built out of lots of little individual pieces because if you chop down one wood wall, you have to be able to pluck that part out of and have what's remaining not look like crap. Um, you've got to have all the stuff for when you do the building, which is just crazy. Like that's one reason I could never really get into it. That you start shooting at somebody and suddenly a fort appears. Uh, so, um, right, okay. So, all of those different kinds of assets are right, things that you would have to manage in the engine. And many of them would be produced or edited or whatever in separate software from the engine itself. Okay, so this is going to be things like 3D Studio or Maya for the modeling, um, different Adobe products like Photoshop, for example, for doing the texture work. And then you kind of bring it all together. It's a horrendously complicated process, and I don't even know all the parts of it. Like modeling, I can handle. The texturing part is just I'm not that kind of brain. Um, okay, now fortunately for us, uh, there are a lot of free pre-made assets. Okay, in particular, so Epic makes Infinity Blade on the mobile games, and there were several of those. So all of those assets and a bunch of other things, they have basically put on there's a separate store that goes with the game engine for assets within the game, plugins, yeah, different animations, different static, right? You can get all kinds of art, and a lot of it actually is free, including most of the stuff that Epic has produced. So you can take Infinity Blade assets and make something with them. And for us, since we're not trying to sell games, it's all free, right? So, yeah, same thing here in MakeCode, right? Even though everything in MakeCode is going to be, so we'll go to the gallery here, say, everything in MakeCode is basically just a 2D piece of graphics, that's it. There's a lot of stuff that's built in. Now, some of it's kind of lame, right? Like, I don't know why we would need hamburgers and pizzas in a game, but of course, on the other hand, why wouldn't we? Um, so I got an argument actually yesterday with people. Would you guys consider a hamburger to be a sandwich? Yeah? Okay. Um, no? Why not? Yeah. Okay. Or is an ice cream sandwich a sandwich? No. Okay. Is a burrito a sandwich? Or is a hot dog a sandwich? No. So, feel like we're going to have everybody at fisticuffs by the end of class over what's the definition of a sandwich. Is lasagna a sandwich? Well, exactly, right. That was the whole joke. But anyway, so there's a lot of assets built in here, and some of them are like, for example, this character thing here would be like, let's say you were making sort of one of these old style um, vaguely Japanese RPGs like Final Fantasy or, the old school stuff, right? So you've got this guy, or Zelda, say this would maybe be a bit more accurate for Zelda, right? All of the different poses for him using a sword or walking around or whatever, uh, somebody's made all of these. And if we wanted to do something like this from scratch, we would have to make every single one of those things, which is kind of a pain in the butt. Um, okay, so there's all kinds of different assets in here that we can use, but let's just take an item. Well, let's just go back up to the foods, the pizzas and stuff. All right, so let me just say, I'll just pick the hamburger. Oops. It does, yeah. Um, so if you go to, I think, edit, um, where is it? Uh, yeah, there's a way you can import stuff. I'm pretty sure. Okay, so anyway, now I've created a hamburger. Okay, great. Um, and then what I'm going to do is I can say set my sprite to sprite um, hamburger of type food. Okay, so this is what I mean when I say this thing is object oriented. So the sprite hamburger is the visual display of it. Okay, the type of thing that it is, which in MakeCode they call it kinds, okay, but this would be sort of like the class of object, is food. Okay, so I could also have tacos that are foods, right? And so if I want to say I'm building a game and there's skeletons and there's hamburgers and tacos, if you walk up and you touch a skeleton, something bad happens. But if you walk up and touch a hamburger or a taco, something good happens, right? Well, if I make the hamburger and the taco both things of type food, then I just have to say, okay, if I touch something of type food, I know that I can do the food thing. If I touch something of type enemy, I do the enemy thing, right? But I've got these things sort of in separate categories or classes. And then this particular hamburger that's on the screen is called my sprite. Now, obviously, I could name it something else, okay? But if I wanted to have two hamburgers on the screen, say, then let's just do that. So let me call this guy ham1 and ham, right? And then, okay, so right now you only see one because they're on top of each other, but you get the idea. So these are both instances. Each hamburger one, that's actually the hamburger on the screen, is an instance of the object that's the hamburger art, which is itself an instance of a food object, right? So if we sort of categorize this, there's food, then there's the hamburger sort of archetype, and then we have two instances of that hamburger. Okay, does that kind of make sense? Yeah, okay. Um, and the reason, like, it may seem a little pedantic or overly complex to talk about it like this here, but that's exactly how everything is in Unreal Engine. Okay, everything is object oriented. So you have in Unreal Engine, you have, for example, the biggest class, or one of the biggest ones, is the actor class. Okay, and beneath that, you've got different categories like a pawn, which is anything that basically can move around. And within that, you've got different categories of pawns. So is it something that, like, is it a player controlled thing? Is it an AI controlled thing? Um, you also have static meshes. You've got, right. So everything is sort of organized in these hierarchies. And if you want to create new objects, they're going to have to fit into that hierarchy in some way, right? So if you want to build static meshes, well, it's just a static mesh object. If you wanted to build a player or a vehicle or something like that, it's going to be um, something of the appropriate type. Um, and the engine here has, right, there's nothing special about the word food, right? But it comes with four of them that are sort of defaulted just because, you know, it's just set up for going ahead and getting started. Player, projectile, food, and enemy. But you can, of course, have as many kinds as you want. Okay. So I could have called this kind, uh, fast food or slow food or fancy food, or, right. I could have had different things. The actual name of it is completely irrelevant. Um, Obviously, though, you would want to pick a name that's somewhat logical. Okay. Because if you just called it ASDF, not very descriptive. And if you hand your project off to somebody else, it's going to be looking at it and being like, what the heck is this guy smoking? Right. Like, and may I have some? Um, yeah. So, don't do that. Be descriptive with your things. Okay. Now, um, if I, for example, let me, let me move this one over to the top left. And actually, let me move it to say 16, 16. Okay, then my two hamburgers are in different positions, and now I actually know that I have two different objects, even though they're members of the same sort of category of objects. Okay, does that kind of make sense? Yeah. Okay, so what all can you do with this thing? Well, you can do lots. So there, all we did was we just created the existence of an object, okay, at the very beginning. And obviously, if I can create the existence of an object, that's the very first thing I've got to do. I can control where the thing is and how fast it's moving, if at all. Okay. I can modify how it looks or how it behaves. They've got some really nice stuff in here. So, for example, um, you can make it so that if it hits the edge of the screen, it bounces off, and you don't have to do all the physics and stuff yourself, which is kind of handy, right? Um, then there's this thing called auto destroy, which, so if you can create a sprite, you can also destroy a sprite, right? Which just sort of deletes it from existence. Now, you're not deleting the category from existence, you're just deleting that actual individual object, okay? Um, and, you can make it say things or whatever. You can do projectile stuff, which is basically it handles some of the physics for you for how to make something move from one place to another and look decent. Um, and then, well, for example, like this, right? So how could I make it so that, um, if I were making a game where I wanted to walk around and if I touch a hamburger, then like it adds a health point or something, right? Well, I need to know whether or not the two things are touching. And that little block right there does that. On sprite of kind player overlaps other sprite of kind player, but you see how the player, they have the little arrow next to it, right? The thing that fits there would be any kind of class, okay? So what I could do is just say, okay, on sprite of kind player, overlap other sprite of type food. What am I going to do? Well, that's what goes inside that little block. Okay, whatever happens when you touch a food item. Okay, so if I touch a food item, what kind of thing might need to happen? Just say, huh? Yeah, the food item should disappear. Okay, which probably means we need to either hide or delete the object. Uh, Maybe you add a health point or something, and you play like a sound effect. Okay, doesn't have to be complicated, right? But several things need to happen, and whatever happens on in that condition is what goes inside this little socket, if you will. Okay. Then the little sprite and other sprite thing are um, would be how, for example, you could say like, well, uh, let's say that if you eat a taco, you get 1 health point, but if you eat a hamburger, you get 2 health points. Okay, those are different things. So there's a couple ways we could handle that. One would be you have like a hamburger category and you have a taco category. Okay, but then I have to have two of these little things. One to check whether or not I'm overlapping a hamburger, the other to check whether or not I'm overlapping a taco. Okay, is that kludgy? Well, it's a matter of opinion. Okay, the other thing I could do is say, okay, hamburgers and tacos are both instances of food. If I touch a food item, well, then this would be which object did I touch? What's its name? Okay, and if so, it says other sprite, but like let's say I've made my player and I actually touch the hamburger object called ham2, then this is actually ham2 because that's the thing I touched. Okay, and then I could say, okay, well, if the label for the sprite starts with an H, then I know it's a hamburger. If it starts with a T, I know it's a taco or whatever, right? So does that kind of make sense? Yeah. Um, and I'm talking real sort of general here. Um, okay. Uh, you can have when things get created, something automatically happens, or when they are destroyed, something happens. Um, and you can say, okay, I want a list of all the tacos that are currently in existence, right? I want a list of their names. So if you ran, um, that, then it'd be like, okay, I've got taco one, taco two, taco three, say. And then I could be like, okay, randomly delete a taco. I don't know. Um, and then you can also set the image to something. So that would be useful if, like, let's say, for example, um, let's say that you had like a jewel, like a ruby or something. Uh, it'd be the same object, but you might want to have its art sort of change as it, like maybe it's shimmering or something, right? Or glowing. Well, you could do that. You could say, okay, I want the sprite to say ruby to use this image and then this image and then this image and loop back through it to make it look like it's shimmering or something. It's still the Ruby, but the art that's attached to it is different over time. Okay, is that kind of, yeah? Yeah. Okay. Um, all right. That's all just for the sprites, of course, and then there's a whole bunch of other stuff. So controller would be everything to do with the button pushing. Okay, so either the arrows or the A and the B key, right? And, is it pressed, control something with buttons. When a certain button is pressed, do something. You can do multiplayer in this thing where it's a little bit of a pain if you're doing it on a keyboard, right? Because you've got to both be huddled over the keyboard. But you can actually get um, I think your Xbox controllers you can hook up to a computer, no problem. Or you can get, lots of third party people make simple little like Nintendo style controllers that you can hook up to the keyboard or to your machine. And then I could just map, okay, the button A is going to be this button on this controller, and the arrow keys are going to be these arrow keys on this controller. And you could sit there with two Nintendo controllers and, go to town. Um, Okay, so there's a bunch of button stuff. There's a bunch of game stuff, which is going to be, we'll talk about the game update stuff later. You've got a game state for win and lose. You've got time since the beginning. So if you're making a timer, then you could do that. You can sort of force a reset. Um, you can do all the dialogue-y stuff. So imagine well, I don't know. I guess the Pokemon games had plenty of that, right? Where you'd walk up to something and then be like, no, I am the greatest trainer of all. And then you hit A, and then your character would be like, no, but I am the greatest trainer of all. And then, or I'm a little too old to have experienced Pokemon as a child. You guys all did though, right? Yeah, when you were like 8, you were probably a Pokemon fiends. Any of you guys still Pokemon fiends? Oh, okay, good. Just making sure. Yeah. No, I'm a little too old for Pokemon. It like became a thing when I was like 14 or 15, and by that point, I was like, I didn't even know it happened. I was so oblivious to what was going on in the world or in popular culture. Let me be frank. Um, okay, so you can do all that kind of dialogue-y stuff. You can have music. Now the music is kind of lame the way that they did it, because you can basically program melodies and you can make play sound effects, but there's no way to like import like an MP3 or something for audio, which is kind of lame. But on the other hand, it's kind of retro. Um, I don't know. Maybe they just didn't want to have to deal with copyright, with people uploading MP3s illegally or something. I don't know. But whatever. So the music, right? I mean, we're not going to get super, super into MakeCode, right? Because the whole point is that we are eventually switching over to Unreal Engine. Scene would be so the way that old Nintendo games worked uh, is that they had a tile map, and you would designate, okay, different tiles would make up your screen, okay? And so here it would be like, let's say that you were, I mean, how many of you guys did this when you were kids where you had paper and crayons and you made a game and you imagined that it was on your Nintendo, right? And you drew a map, and that, right, so your map that you draw is like your tile map, right? And it's built out of individual pieces, uh, blocks and trees and treasure chests and things of that sort. And so you can build that. Time to wake up. Um, okay. Stuff for how the player or any other object for that matter interacts with the walls or whatever. Um, how to deal with collisions, how to deal with camera, all that stuff. Info would be things like you've got variables that keep track of what your score is, how many health points you have, countdown stuff, things of that sort. Okay, and then here's where it starts to really get into programming. Okay, um, which is, so what makes programming fundamentally is the ability to make decisions. So if something is true, then do X, or to repeat procedures over and over, okay? Either until some condition is filled, or we do it a certain number of times, or maybe even forever, okay? So most of your games actually are just loops, forever loops. And it's basically until the player presses the exit button, run the game. And then when you hit exit, then it quits, okay? Um, so if I wanted to make 500 hamburgers, do I want to do hamburger one, hamburger two, hamburger three, hamburger four, hamburger, right? No, that would be silly, right? I would not want to do that. Okay. So what I could do instead is say, all right, I want to repeat some procedure some particular number of times to say create a bunch of hamburgers or create a bunch of random enemy ships that I need to shoot or something. I don't know. Okay. Um, and then break and continue. We'll talk about that later. Uh, what else do we have in here? Onstart, which you'll notice is exactly what starts there. So when the game is initially run, this is what code is executed. Okay. Um, Logic would be your if-then kind of things. Uh, you can do comparisons to check whether or not numbers are less than or equal to or greater than or whatever. You can also do Boolean operations. So let's say that you were making a game where there's a locked door, and if you touch the locked door, what happens?
Get shot.
Nothing, say,
Okay.
right? Uh, but then what happens if you have the key and you touch the locked door? Okay, right. So then you would have a situation where you would say, if player is touching door and has key, do something, right? So there we need the word and or not, right? So you can build up any logical thing, anything that can be evaluated to true or false by a big combination of ands, ors, and nots. And let me just throw this one down. Okay. Now, those of you who took 101, or actually, has anybody taken the Dr. Carlson in philosophy symbolic logic class? Anybody? No? Okay. Um, there are more logical operations, so for example, XOR and NAND and whatnot, but you can build all of those out of AND, OR, and NOT. So they're there even though they're not a primitive object. Okay. Variables would be a variable would be anything. An object is a variable, a number is a variable. A true false thing is a variable. Okay, they're variables of different data types. Numbers are different than hamburgers. Okay, but you can create them, you can set their values to something. Although with the hamburger, that doesn't really make sense, right? Like, what does it mean for a hamburger to be two? Um, okay, but you can do that. And then, of course, my favorite, right? You can do math, um, random numbers, pretty much any math function you could want. And then the advanced stuff has got stuff for like how to do animations. So this would be how we would probably want to do, like, let's say we had the Ruby that was shimmering. We'd probably use this sort of thing. Um, and images, um, probably won't really need that. Functions, so we can make a function. So let's say, for example, I want when the game starts to create 5 hamburgers and then do something else. Well, I could make a function that's called make hamburgers, and everything involved in making the hamburgers I'll put over there in that function, right? So let me just do that for sake of demonstration. Make a function, and we'll call it make burgers, okay? And then I'm going to define the function over here, and let's say this is what that function does, okay? And then when the game starts, what do I want to do? I want to call the function make burgers, Okay, so this will say, okay, I just started, call the function make burgers, which is over here. Do this stuff. Okay, and then when I'm finished, so for example, let me just throw something in there. Um, okay, something like this. Okay, so what would be the order of execution here? The burgers would be called make burgers would be executed. It would run through this stuff, and when that's all finished, then it would return back here and say burgers are made. Okay, so does that kind of make sense, the flow? Yeah. All right, so we're getting kind of close to the end here. Yeah, go ahead.
So everything revolves around the start.
Yeah, to start, right? And then your game would be, you'd probably have a function for like level one or something, right? Okay, now, how many of you guys have done any kind of textual coding? So JavaScript, Python, C, anything of those sorts. Yeah, okay. Well, this is one reason that I really like MakeCode. Same project, magic button, now there's a Python, okay? And if I change something here, so like let's say that I change the position of it, okay, and I go back to the blocks, it reflected that change, right? So what's kind of neat is that you can sort of go back and forth between block, visual coding and Python. That's you can't really do that on Unreal Engine, but you sort of, but it's not nearly that easy. So what this means though is that like if you're trying to teach a novice programmer, you start them out with block stuff. As they get more advanced, you could say, oh, look how this is in block language. Now look how it is in Python or JavaScript, and then you can kind of see how big boy code looks. Okay, so that's pretty much the get-go. All right, so let me go back over to Canvas for a moment, because you got assignments, right? So what I want you guys to do um, before you get to class on uh, Thursday. All right, so there's an assignment here, but if you go to, so if we're here in MakeCode, let me just go back to my home thing there. All right, there's this thing here, Game Maker Guide. So click that, and I'll open up the skill map. And what I'd like you guys to do is do this one, learn to use MakeCode Arcade, and then also this one, design a space explorer. Okay, so let me just show you what one of these looks like. Okay, so at the top in that little white space, it's got basically like, okay, here's what we're gonna do, right? And then if we hit next, it's gonna tell you to do some stuff. Then you're gonna do it actually below. And if you follow those steps through the different things, then you guys will have the beginnings of like a simple little space shooter game before you even show up on Tuesday. Okay. Then on Tuesday, we're going to add cool shit to that. Or, well, you guys will do it, but you'll come up with cool shit to add. Okay. Now, when you finish, so for example, let me just take this and say that I've finished. Okay. And I've got a bunch of stuff. Then what I'd want to do is hit save to my projects. Okay. And now I'm outside of the tutorial thing. And if I go back to my home, I have my fuel up thing that I can return to. But in particular, I can hit the share button, okay? And then I would say publish it. That gives me a link or a QR code. And this link would be how we could share projects between each other, okay? And, oops, let me go back here. Let's see, where is it? Yeah, okay, so does that kind of make sense for how to get started for Thursday? You guys, I think, will be a little surprised at just on the one hand how easy it is, and on the other hand how complicated some other parts can be. Yeah, okay, but that's your homework, if you will, for Thursday. And then on Thursday in class, we'll talk about, okay, we made the space shooter. What other stuff would we want to do rather than just following the tutorial? Okay. All right. Well, it's fun, gentlemen. See you guys Thursday. Yeah. So what you guys will do, let me go back to Canvas here, is when you're done with the Space Explorer, you'll submit the URL, right? So all you got to do is copy and paste a URL and submit it. Like there's a little text box. But here's the thing. You got to make sure that you actually publish the project. Because if you publish the project or you don't publish it and you give me a link, I can't see it, right? So, yeah. And somebody's already done it. Who's already done it? Ethan, you've already done the whole thing? Oh, okay. Okay, just get to it. Yeah. All right. Well, uh, yeah. So Thomas, sorry, I just saw the message. The set image block. You could use it for animations, but as we saw, there's a special thing for animations that you could use instead. That'd probably be easier. So, all right. See you guys.